A very good day to doctors. So we are from Group 1. Our group project is Pneumonia Detection Device Design based on embedded technology and CMSIS neural network. I'm Ooi Tze Kian. I will start the presentation now. So based on World Health Organizations, there have been around 3 million confirmed cases from 2020 to 2022 of COVID-19, and around that 30,000 of them causes death. So one of the compilation of COVID-19 is actually the pneumonia. Pneumonia is an infection of the lungs that can cause the alveoli to fill with the fluid. So how can we diagnose the pneumonia? We can do it by various methods. That is, one of them is the respiratory sample collections, chest X-ray, and also blood samples. So if you look at here, the chest X-ray for different patients with bacterial pneumonia, COVID-19 pneumonia, and viral pneumonia. So the problem statements of our project is actually in the current situations, the healthcare provider is overloaded with lots of X-ray images since COVID-19. It may cause misdetection because it's human error and also large samples of a large number of samples. And beside that, most pneumonia detectors models implemented in using the advanced machine, which require high cost and high power. So based on the problem statement, our objective is to design a pneumonia detector based on the artificial neural network using edge impulse platform that targets the embedded applications. And from that, we will develop a proof of concept lab demonstration prototype by deploying the trained pneumonia detector neural network model in the first point onto a STM32 development board. After that, we will conduct the system functionality verification and performance measurement in terms of the model accuracy. So the neural network model training follow this flow here. We will use the dataset from the Kaggle, and from that we will go to the Edge Impulses, which is a free open source web platform to create impulses, and we set the RGB as our color depth as a parameter. Next, we generate the features and start the training. And while doing the trainings, we will continuously monitor the accuracy and also the latency. And once the validation is satisfied, we will be ready to deploy to the STM32 board, which will be explained by my next teammates. Thanks.
Hi, my name is Salehuddin. So I will show you how we deploy our train model into the QIDE. First, after we have trained the model, we can download the CMSIS pack into our local machine. And then, to deploy it to our QIDE, we go to Help, we go to the Manage Embedded Software Package. From local, we browse our project. For example, this is our project. And then we just open and just follow the necessary step guided by this IDE. So if it's successfully being uploaded into this IDE, we can see here in the software packs, our project is here. So we just tick here, and then we save the configuration, and then some of the files are generated here. So the main file that important is the middleware file, which all our model and also some of the script that we are required into our main program is here. So the first one, we need to include the EI run classifier, which is here. So, and then we initialize the array of features for our input data, which is the normal sample and the pneumonia sample. So this will explain further inside the demo. And then we also initialize to the get feature function to get the feature of the input data. And then we jump straight to our main program, which is inside the while loop. So some initialization occur here, such as total length, the get data which come from the get data function that I explained before this. And then this program will first check if there is an error here. This function is inside this EI run classifier.h. So if if the parameter of the error met the error result, so it will tell the user there is an error, we need to fix it. If not, it will print the timing of the DSP, classification, and the anomaly in millisecond. Okay, next we will start the prediction. In the prediction, the first thing that will be see is the anomaly. Anomaly is the situation we put foreign features uh, that are different from our trained model. For example, we train the lung images, but we put a car images features into this program, so the anomaly will be detected. If we put the correct data, and then this chunk of code can be skipped, and then just jump straight to compare the score between the pneumonia lung and also the normal lung. If the score of detection of the pneumonia lung is higher than the normal lung, so it will print this pneumonia lung, and vice versa. If it detect the normal lung classification score is higher than the pneumonia lung, so it will say that this is a normal lung. And else, if there is anomaly like before, it will print this is uncertain data feature. So that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhaimin bin Hashim. Okay, so for now, I will explain how does we can apply the neural network through the SM32 board. Okay, as you can see here, this is the code. Okay, this is our code. So I want to test so the part that you need to change is just over here. So meaning that you just need to paste a raw feature. So let's say, right, I want to test a raw feature of Pneumonia over here. So then the next thing is that make sure your board is already connected, so that you can feed the code into the board, and then you just run. Okay, please make sure it's already set the download verified successfully and the shutting down and exit. Next is that you need to open your interface, the putty. So this now I'm using putty. So this one is 19.3 and 1152 is the speed. And then just open. Yeah, you see. And then it will define is a dependent lang over here. So let's say, right, if you want to define another thing is that, okay, over here is the phenomena. Okay, correct. And then I want to test this raw feature. So I just need to run again this code. Okay, it's download very fast, successfully shutting down and exit. So now we can see that over here it will change this is a normal lang. So how does I get the raw feature? Okay, the raw feature I can get from this Hashim impulse over here. So let's say I want to test this raw feature, right? I will load the example, load the sample, and then waiting. Okay, this is the raw feature over here. So basically, you just copy this raw feature, and then you see this category over here is phenomena, and then after you copy that one, right, you just need to paste the raw feature over here, and then you just need to run the GitHub, run the code, so that it will fit the code into the board. So basically, we can expect is that we can expect the the result to be phenomena lang lah. Basically. So basically, it says download very fast successfully set dot exit. Okay, and then we can see that this is phenomena lang over here, showing this is phenomena lang. So basically, our code is okay. And then how does the coding work is that this is the middleware. So you need to make sure your middleware is over here. So my bad. How does the CMSIS spec is applied is over through the middleware over here. So if you open the middleware, right, you can see there is the CMSIS spec over here. That is the neural network. So basically, we need to make sure this middleware folder is existed, so that we can use the neural network CMSIS library for our milestone. Okay, that's all from me. Thank you.